Have you ever asked a simple question and realized the answer was much stranger than you expected? Why do stars seem to blink in the night sky? Why does the sunset turn blood red? Why can an octopus disappear in front of your eyes? Why do deserts become freezing cold at night? Why do some animals know an earthquake is coming before humans feel anything at all? And why does your own mind sometimes remember things that never truly happened? The world is full of hidden mechanisms, invisible forces, ancient instincts, strange natural tricks, and impossible-looking events that are actually real. Tonight, we continue our journey into the questions most people forget to ask. Questions that begin with one small word. Why? But behind that word, there may be a secret door into the deep machinery of reality. This is 10,000 Why Questions, Episode 2. Why do strange things happen in nature and inside?
The human mind. Question 1. Why do stars twinkle?
Look up at the night sky. A star appears. Then it flickers. It brightens. It dims. It changes color for a split second. It almost looks alive. For thousands of years, people watched stars twinkle and imagined they were messages from gods, spirits, or distant worlds. But the real reason is closer than the star. It is our own atmosphere. A star is so far away that, from Earth, its light reaches us as a tiny point. Before that light touches your eyes, it must pass through layers of moving air. Warm air, cold air, air with different densities, air shifting above deserts, mountains, oceans, and cities. As the starlight passes through these uneven layers, it bends slightly. Then bends again. Then bends again. To your eye, the star appears to jump, shimmer, and flicker. That is twinkling. The star itself is not blinking. The sky above you is moving. This is also why planets usually twinkle less than stars.
Planets are much closer to Earth, so they appear as tiny disks instead of single points of light. The atmosphere still distorts their light, but the effect is spread out. A star is like a needle of light. A planet is like a tiny glowing coin. So the next time you see a star flickering in the dark, remember this. You are not watching the star change. You are watching Earth's atmosphere dance in front of the universe.
Question 2. Why does the sunset turn red? A sunset can make the sky look like fire, orange, gold, crimson, deep red. For a few minutes, the whole horizon seems to burn. But why does this happen? The answer begins with sunlight. Sunlight may look white, but it is made of many colors. Blue light has a shorter wavelength. red light has a longer wavelength. During the day, when the sun is high above us, sunlight takes a shorter path through the atmosphere. Blue light scatters easily in all directions. That is why the sky often looks blue. But near sunset, the sun is low on the horizon. Its light must travel through much more atmosphere before it reaches your eyes. A longer path means more blue and violet light gets scattered away. The red, orange, and yellow wavelengths survive the journey better. So by the time sunlight reaches you, the sky has been filtered. The blue has been removed. The red remains.
Dust, smoke, water droplets, and pollution can make the colors even stronger. That is why some sunsets look gentle and others look almost apocalyptic. A red sunset is not the sun changing color. It is the atmosphere revealing what light is made of. For a moment, the sky becomes a prism, and the world ends the day in fire.
Question 3. Why do deserts get so cold at night? When people imagine the desert, they imagine heat, burning sand, dry wind, sunlight so intense it feels like the air is on fire. But many deserts become shockingly cold at night. How can the same place feel like an oven during the day and a freezer after sunset? The answer is water, or rather, the lack of it. Water holds heat very well. Humid air, wet soil, forests, and oceans can store heat during the day and release it slowly at night. But deserts are dry. The air contains very little water vapor. The ground often has little vegetation. Sand and rock heat up quickly under the sun, but they also lose heat quickly after the sun disappears. With little moisture in the air to trap warmth, heat escapes rapidly into the sky. So the temperature can fall fast. In some deserts, the change between day and night can be extreme. The desert is not only a place of heat, it is a place of contrast.
The sun gives energy quickly. The night takes it away. And beneath a sky full of stars, the same sand that burned your feet at noon can become cold before midnight. That is the strange truth of deserts. They are not just hot. They are empty enough to forget the warmth. Question ball. Why can an octopus change color so fast? Imagine an octopus resting on a rock. For one moment, it is brown, then gray, then red. Then it becomes almost the same color as the sand around it. Its skin seems to think. It changes texture. It changes pattern. It disappears. How can one animal transform so quickly? The secret is hidden in its skin. Octopuses have special pigment cells called chromatophores. Each chromatophore is like a tiny colored sac. When muscles around the sac stretch it, the color becomes more visible. When the muscles relax, the color shrinks back. By controlling thousands of these cells, an octopus can create patterns across its body in an instant. But that is only part of the story. Some octopuses can also change the texture of their skin: smooth, bumpy, spiky, rock-like. They do not just copy color, they copy shape. This helps them hide from predators, sneak up on prey, and communicate with other octopuses. What makes it even more astonishing is that octopuses are extremely intelligent. They can solve puzzles, open jars, escape tanks, remember places, and use their bodies like living illusions. An octopus does not wear camouflage, it becomes camouflage. In the ocean, where danger can come from any direction, being invisible is not magic, it is survival. Question 5. Why do some animals sense danger before humans? Before an earthquake, some people claim animals behave strangely. Dogs bark without reason. Birds fly away. Snakes leave their hiding places. Fish move in unusual patterns. Is this just imagination? Or can animals sense something humans cannot? The answer is not simple. Animals may not be predicting the future, but they may be detecting signals that humans miss. Many animals have senses far sharper than ours. Dogs can hear frequencies humans cannot hear. Birds can detect changes in air pressure and magnetic fields. Some animals may feel tiny vibrations through the ground before humans notice shaking. Others may react to changes in smell, sound, electricity, or environmental pressure. Before a major natural event, the Earth can produce subtle changes, tiny movements, low-frequency sounds, chemical shifts, vibrations too weak for human bodies to register. To us, nothing is happening. To an animal, something may feel wrong, but scientists are careful. Not every strange animal behavior means disaster is coming. Animals can react to many things: weather, predators, human noise, temperature, stress. So the mystery is not fully solved. But one thing is clear: humans do not experience the world completely. We see only a slice. We hear only a range. We feel only what our bodies are built to feel. Animals live inside the same world, but with different doors open, and sometimes they may hear danger whisper before we hear it roar. Question 6. Why do whales sing? Far below the ocean surface, where sunlight fades and pressure rises, a sound moves through the darkness. Long, deep, haunting, a whale song. It can travel for enormous distances underwater. It can rise and fall like music. It can repeat patterns like a language. But why do whales sing? One reason may be communication. The ocean is huge,
and visibility underwater is limited. Sound travels much better through water than light. So, for whales, sound is connection. A whale can sing across dark distances where eyes are almost useless. Some whale songs may help males attract mates. Some may help groups stay in contact. Some sounds may guide movement, feeding, or social behavior. But whale song is still mysterious. Humpback whales, for example, can produce complex songs that change over time. A song can spread through a population. It can evolve. It can be copied. It can fade and be replaced by a new version.
That makes whale song feel almost cultural, not just instinct, not just noise, but something learned, shared and transformed. Imagine a song moving across the ocean, from one whale to another, until an entire region begins singing a new melody. In the deep sea, there are no concert halls, no instruments, no written notes, and yet the ocean is full of music.
Question 7. Why do trees seem to communicate underground? A forest looks quiet. Trees stand still. Branches move only when the wind touches them. But under the soil, something much more active may be happening. Roots spread through the darkness. Fungi grow in thin threads. And together, they form hidden networks. Some scientists study how trees and fungi exchange nutrients and chemical signals underground. The fungi can connect with plant roots. The trees provide sugars created through photosynthesis. The fungi help gather water and minerals. This relationship is called a mycorrhizal network. Some people call it the Wood Wide Web. But we should be careful with that phrase. A forest is not the internet. Trees are not texting each other like humans. Still, the underground connections are real and fascinating. Through roots and fungi, plants may respond to stress, share resources, and influence each other's growth.
A tree attacked by insects may release chemical signals. Nearby plants may prepare defensive responses. Nutrients may move through shared fungal networks under certain conditions. A forest is not just a group of individual trees. It is a living system, a community, a slow conversation made of chemistry, roots, moisture, and time. The silence of a forest is not empty. It is simply speaking in a language too slow for us to hear.
Question 8. Why does time feel faster as we get older? When you are a child, a summer can feel endless. One school year feels like a lifetime. A birthday takes forever to arrive. But as you get older, weeks disappear, months vanish, years seem to pass faster and faster. Why? Time itself is not speeding up. The clock is not lying. But your perception of time changes. One reason is proportion. When you are 5 years old, 1 year is a huge part of your life. It is 1/5 of everything you have ever experienced. But when you are 50, 1 year is only 1/50th of your life. It feels smaller in comparison. Another reason is memory. New experiences create stronger memories. As a child, the world is full of first times, first school, first friend, first storm, first fear, first discovery. The brain records many details because everything feels new. But as life becomes more routine, days may feel similar. Wake up, work, eat, scroll,
Sleep, repeat. When fewer unique memories are created, the past seems compressed. A month with no surprises may feel short when you look back. But a week full of new places, new people, and new emotions can feel much longer. So if you want life to feel slower, do not only count time. Create memories. Break routines. Learn something new. Go somewhere unfamiliar. Ask better questions. Because time feels fast when the mind has nothing new to hold.
Question 9. Why do we remember things that never happened? Memory feels like a recording. We imagine the brain storing the past like a video file. Press play and the truth returns. But memory does not work that way. Memory is not a perfect recording. It is a reconstruction. Every time you remember something, your brain rebuilds it. Pieces of sight, sound, emotion, meaning, expectation. Sometimes the brain fills in gaps. Sometimes it mixes events together. Sometimes a story you heard later becomes attached to a memory from the past. And over time, the false detail can begin to feel real. This is why two people can remember the same event differently. One person remembers the room as dark. Another remembers it as bright. One remembers a sentence being said. Another insists it never happened. They may not be lying. Their brains may have rebuilt the past in different ways. This is also why suggestion can affect memory. If someone asks, "Did you see the broken glass?" your brain may begin searching for broken glass, even if there was none. The question itself can shape the memory. That is unsettling. Because memory is tied to identity. We are made of what we remember. But if memory can change, then the story of who we are is also flexible. Not fake, but alive. Your memory is not a museum. It is a storyteller. And sometimes the storyteller edits the past. Question 10. Why do people feel like they are being watched? You are alone in a room. No one is behind you. No sound, no movement. And yet,
you suddenly feel it. Someone is watching me. You turn around. Nothing. So why does this feeling happen? Humans are social creatures. For survival, our brains became extremely sensitive to eyes, faces, and attention. In the wild, noticing another creature looking at you could be the difference between life and death. A predator watching from the grass, a stranger hiding in the trees, a rival reading your movement. So the brain developed systems for detecting gaze and presence. But these systems are not perfect. Sometimes, in darkness, silence, stress, or fear, the brain becomes too alert. It searches for danger. It interprets shadows. It fills empty space with possible threats. The feeling of being watched may come from this survival system. Your brain would rather make a false alarm than miss a real danger. This is called a bias toward safety. If you think something is there and you are wrong, you lose a little comfort. But if you think nothing is there and you are wrong, you may lose everything. That is why darkness feels crowded, why empty houses can feel alive, why a forest at night seems to have eyes. Sometimes the watcher is not outside you. Sometimes it is the ancient alarm system inside your own mind. Question 11. Why do magnets attract and repel? A magnet seems almost magical. It pulls metal without touching it. It can push another magnet away. It can move objects through paper, plastic, or thin wood. How can something pull without a visible rope? The answer is the magnetic field. A magnet creates an invisible field around itself. This field has direction. It flows from one pole to another. When two magnets come close, their fields interact. Opposite poles attract. Like poles repel. Inside magnetic materials, tiny regions called domains can line up in the same direction. When many of them align, the object becomes magnetic. That is why some materials are attracted strongly to magnets, while others are not. Iron, nickel, and cobalt respond well because of their atomic structure. Wood, plastic, and glass do not respond the same way. A magnet is not breaking the rules of nature. It is revealing a force that is usually invisible to us. We cannot see magnetic fields directly, but we can see their effects. A compass needle turning north. Iron filings forming curved lines. A magnet lifting metal from a table. The invisible becomes visible only when something responds to it. And that is one of the strangest truths about the universe. Some forces are everywhere, but we only notice them when they move something. Question 12. Why do humans keep asking what if? What if there is life under the ice of another planet? What if ancient civilizations knew things we forgot? What if the ocean still hides creatures we have never seen? What if dreams are more important than we think? What if time, memory, and reality are stranger than they appear? The phrase "what if" is one of the most powerful tools in the human mind. It allows us to imagine danger before it happens. It allows us to invent tools before they exist. It allows us to build stories, science, art, and civilization. Every discovery begins with a question. Before the airplane, someone asked, "What if humans could fly?" Before deep-sea exploration, someone asked, "What if life exists in total darkness?" Before space travel, someone asked, "What if Earth is not the only world we can touch?" Curiosity is not just a habit, it is the engine of progress. It pulls the human mind beyond what is known. It turns fear into investigation. It turns mystery into knowledge. And sometimes, it turns impossible things into ordinary things. That is why questions matter. A question is not a weakness. It is a door. And the person brave enough to ask may be the first one to step through. Ending. Tonight we asked why stars twinkle, why sunsets burn red, why deserts freeze at night, why octopuses vanish, why animals may sense danger before us, why whales sing, why forests may communicate underground, why time feels faster, why memories can lie, why we feel watched, why magnets pull without touching, and why humans never stop asking, "What if?" The world is not running out of mysteries. We are only beginning to notice them. So the next time something feels ordinary, look closer. Ask why. Because the answer may be hiding in the sky, beneath the ocean, inside a forest, or deep within your own mind. This has been 10,000 Why Questions. Stay curious because the next question may change the way you see